Okay, so we're looking at DEB 2017, paper 1, question 5, and it's Leaving Cert higher level maths. So it's a real life logs question, an exponential question as well, I suppose. So the power supply to a space satellite is provided by means of a generator that converts heat released by the decay of a radioisotope into electricity. The power output in watts may be calculated using the function W of t is equal to AE to the BT. Now, that W of t is not W multiplied by t. It's like a function. It is a function. So remember, f of x does not mean f multiplied by x. It is just the name of a function where x is our variable. Well, in the bracket here is t, so t is our variable. So it's watts in terms of t, would be a nice way to think of it as. Okay. So it's the power at time t, where t is the time in days from when the satellite is launched into space. The initial power output at the launch of the satellite is 60 watts. Now, that's really important. That's 60 watts. Is the initial power at time zero. At time zero, the watts is 60. So that means the left-hand side here is going to be 60 when t is equal to 0. b times 0 is 0. E to the power of 0 is 1. Check that on your calculator. Remember, E is down at the very bottom above the times 10 to the power of x. E is in red just above it there. So you'd be pressing alpha and then this button, and you can put it to the power of 0. Or you can check anything to the power of 0. 7 to the power of 0 is 1 also. Okay, so anything to the power of 0 is 1. And that then helps us find what A is. We know what A is now. So at this point, when you have a new piece of information, you should always use that and rewrite the original formula. So the formula now does not have an unknown in it. It's W of t is equal to 60 e to the bt. So b is now our unknown. So given that after 14 days, the power output falls to 56 watts. I think there's another question that's similar to this that says it falls by 56 watts. So then the final output, the final wattage, would be 4 watts. So just be careful of that word there. It says 56 watts. So we're happy that it's going to be 56 here on the left-hand side. The time now is 14, and 14 by b is 14b. Divide both sides by 60. So 60 divided by 60 is 1, so that's why we're left with just this. Now, how do you know we're going to use logs? People always ask, so at this point, how do I know I'm going to use a log? Okay, well, think on page 21 of your log tables. Page 21, the top right-hand corner, it says a to the x is equal to y. And that is equivalent to log to the base a of y is equal to x. So the way I like to think of it as, if x is my unknown, if my power is unknown, see the way the power is unknown here? If the power is unknown, you're going to use logs. It's a really great note, an idea to know. If the power is unknown, you're going to use logs. So I would also encourage you to write out what your a, your x, and your y is, okay, which I've done here. Okay, so I know that a is equal to e, x is equal to 14b, and y is equal to 14 over 15. So laying all that out, then all I need to do is sub it in to the log part of the formula. Okay, so I've subbed it into the log part of the formula, and I've also divided by 14, because it would have been 14b is equal to 14b is equal to log to the base e of 14 over 15. But I then divide by 14. I can stick that whole thing into my calculator now. Note as well that log to the base e of something is the same as ln of something. So you can use the ln button on your calculator. And we get this here. The power of minus 3. Remember, that's going to be a small number, so minus 3 is the power. So we're introducing the decimal points. We're moving the decimal point 3 places to the left. So 1, 2, 3, so we get 2 zeros afterwards. And then it asks to 3 decimal places. So you can leave it as minus 0.005. And I'm just going to make that a little bit neater. Minus 0.005. Okay, so again, we now know what b is, so we should rewrite our formula. It's w of t is equal to 60 e to the minus 0.005 t. Okay, so the satellite cannot function properly when the power output falls below 5 watts. After how many days will the satellite fail to function? Okay, so now we know we know the power output is 5 watts. After how many days? It's telling you what it's asking for. It's looking for time. It's looking for time. So this is a very similar question to what we just did. Oops. E to the minus 0.005. I've divided both sides by 60. So 5 divided by 60 is 1/12. Look, what do you not know here? You don't know the power. What do you do when you don't know the power? You're going to use logs. Okay, so again, look what I've done. I've written out the full rule that I'm going to use from page 21 of the log tables. I've written out what my A is. It's E. My power is the power that's here. That's there. And the Y is what's on the other side of the equal sign. The Y is on its own there. So again, fill that straight into the log side of the expression there. Okay. How come I've introduced the log? Brilliant. Introduced the log, and I want to get t on its own. So I'm dividing by the minus 0.005, and we're getting 504 days. So really, really nice. Now the next bit of the question, the part B, is the bit that sort of gives people a bit of hassle, but you're going to look at it and go, ah, Jesus, that's fierce easy. Okay, so be positive about this bit, please. So find the value of the constant k. So we're looking for k, and it's in a weird format at the end as well. Okay, so it's saying w of t plus k. So now, kind of like first principles, I suppose. We're subbing in a t plus k, whereas first principles we're subbing in an x plus h, remember, and we were multiplying it out, f of x plus h. So we're similar to that. We're subbing in a t plus k here. We know what w of t is. W of t. I know what w of t is, that's fine. Okay, it's the w of t plus k. So I will zoom out and do the whole question in one here. And what color highlighter is pointer? Light blue. Okay, so our w of t plus k is here. All I've done, well, I know what my capital A was and my small b was. I'm now, where there was a variable of t, I'm now just subbing in t plus k. I'm happy with this yellow bit. It was already found from the previous questions. So here, it is the same as this. Look, w of t plus k, w of t plus k, w of t plus k, a half, w of t. How many unknowns do I have? Well, actually I have two unknowns. It's t and k, but I would expect somewhere along the line for the t to disappear. Okay, so coming from here, explaining this bit, all we're doing is multiplying the half by the 60, and you're smart enough to know that that's 30, so that's where the 30 is coming from. Now, here there's a little bit of a weird shift, I suppose. The power is all connected here. There's a minus and a minus. So I want you to think of page 21 of the log tables and your indice rules, and the very first rule of indices. Actually, hold on, I might be able to get it up. Yeah, so here, page 21 of the log tables, top left-hand corner, rule number 1 here. A to the power of p plus q. So the powers are being added here. We could split it apart. Now, some people would think of using this rule here, the second rule, but it just looks weird with the negative power. So what I did in this question, I've just split it apart to get down to here. Imagine if you were to combine these two brackets. How would you combine the two brackets? Well, the bases are the same. Both bases are e. The power is minus 0.005t and minus 0.005k. Well, if the bases are the same and I'm multiplying, bases are the same and we're multiplying, bases are the same and we're multiplying, bases are the same and we're multiplying, bases are the same and multiplying, you just add the two of them. So here, to come backwards to here, we would add the two powers, but we are doing it in reverse. Okay, well, what does a negative power mean? Well, again, log table is really useful here. Negative power, I can just change it to a positive power and put it under 1. So I've done that up to here. I've changed it to a positive power and put it under 1. Positive power under 1, positive power under 1, positive power under 1. What's on both sides? How they're not present in the next line of maths. They're not present here. How have I gotten rid of them? I've multiplied both sides by the bottom line. I've multiplied by e to the well, it's a plus now, 0.005t, which would get rid of this fraction on the left and that fraction on the right. So all we're left with is this. Only one unknown. Fantastic. I've multiplied both sides by e to the 0.005k, multiplied both sides by it. So I've gotten rid of the fraction on the left hand side and created the k being the unknown on the right hand side, and at the same time I've divided by 30. So that's where this is coming from. 60 divided by 30, 2. Fantastic. Uh-oh. What's unknown? Take a second, pause, maybe look at the previous two questions. What is unknown? It's the power. So we're using this rule again. Write out what your A is, write out what your B is, write out what your C is. Bit that's catching people then as well is the end. They want us to write it in this weird format. Okay. A little bit annoying to try and find. You can put that into your calculator, stick into your calculator 0.005 and hit equals. You'll get 1 over 200. Okay, well 1 over 200 makes the whole question a hell of a lot easier now, because now we're just multiplying by 200 and we're finishing it off and leaving it like that. To be honest, I actually really like this question. I think it's a good one. Really worth practicing. I hope you found the video useful.